we discussed. I just wanted to repeat so that you remember, you can recall actually. There is another figure now that I need to draw. So all the registers in all the banks, in all the banks there are 8 registers, and definitely each register is 8 bit in size. We all know that. So the problem here is, see, all the registers has got the same name. If you go for bank 2, then you have got from R0 to R7. Same thing for bank 3, bank 1, or bank 0. So in whichever bank you go, all the registers has got the same name. That is the problem. So that's why it is important for you people to make sure you know the address of these registers, because though the name is same, they all got a different address. That is what I will be writing now. Okay, the black colored writing is actually their address. This thing is given very nicely in your book. I will mention the figure number, don't worry. So if you have the book, you can see from there. Even if you don't have the book, this one is more than enough to understand. Or this is your figure 2.6 of your book. Alright, so you see that though the registers has got the same name, they have got a different address. So why you need to remember this thing? Just after this topic, we will go for reading the various things of stack. When we'll be in stack, you will see that while push operation and pop operation, you always need to specify the address of the register that you want to push or you want to pop out. Alright, so that's why you need to know the address of these registers, and be careful of the PSW register, because if you remember from our previous class, your PSW determines which bank will be selected. So say if bank 2 is selected and you want to push register, okay, let me change the color so you understand that it's a different thing. Okay, so assume that bank 2 is selected and you want to say push register R4. Then your instruction should be push 14. Remember, push 14 should be your instruction. If you write push 4, it will push the register R4 of bank 0. That is the difference. Right? You will see examples when you go to stack. For the time being, just know that these registers has got the same name, but they have got a different address, and you need to know these addresses. Clear, everyone, up to this?
Yes, sir.
Moving on. Fine. So these are default register bank. I mean, whenever you power up your 8051, by default, register bank 0 is selected. Okay, so if you simply write move, say R5 comma hashtag 06H, that means you are moving into register R5 of bank 0. That is by default bank 0 is selected until and unless you switch to other register banks using the PSW. So if you do not switch to other register bank using PSW, by default register bank 0 is selected. Okay, let me pause over here up to register bank. If you have any query, you can ask. So assuming you don't have any query, so let us move on to stack. Your stack is your register bank, sorry, not register bank, yeah, register bank. Your stack actually is your register bank 1. So register bank 1 is specifically known as your stack. So very simple, the register used to access the stack is called SP, that is your stack pointer register. And you know that your stack pointer is 8-bit. Okay, now let me come to the last one. Okay, before coming to the last point, can anyone tell me what SP contains? I mean, what is the purpose of SP? We discussed it before. What is the purpose of SP? What does SP contain? Anyone?
Sir, the location of the stack registers.
Yeah, somewhat right. To be more specific, we say that the stack pointer contains the address of the next instruction to be executed, isn't it?
Yes, sir.
We discussed it, right? You should always keep it in mind, okay? Always, because this stack pointer will play a very vital role in your coming chapters. So always keep in your mind that your stack pointer will point to the address of the next instruction. So when I come to the last point, that is when 8051 is powered up, SP contains the value 07. So what is 07? Is it a content or is it an address?
Address.
Exactly. This is an address. But remember, this is the content of SP. Try to understand the difference. This 07 is the content in stack pointer, and this 07 is actually an address. Is the difference understood? Have you understood the difference? Your stack pointer itself is 8-bit. So definitely in those 8-bit, I mean, your stack pointer definitely looks something like this, having 8 bits. So definitely in this 8-bit, there are some contents. So what is the content? This 07 is the content. But what is the content in a stack pointer? The content in a stack pointer is actually an address that contains the next instruction. Have you understood up to this?
Sir, is stack pointer and program counter same?
Yeah, same thing. Okay, clear up to this?
Yes, sir.
All right, okay, so you know what is push and pop operation. Very simple. The storing, I mean, if you want to store a register in the stack, then this is known as a push operation. And if you want to pull the contents of the stack, or if you want to take out some contents from the stack and store in a register, that is known as a pop operation. It is very simple. So let us see some examples. So try to solve with me, okay? So this is the code. Move R6 25H. And by the way, this is your example 2.8. Okay. Let me just write over here. Sorry for that. This is example 2.8 of it. So what we are doing, moving R6 25H. So we are moving the value. You know the significance of this hashtag. Move R1 12, move R4 0F38. Then push 6, push 1, and push 4. So this is the starting point. I mean, when we have just initialized, that is stack pointer is 07. When we start, your stack pointer is automatically at 07. So this is your initial condition. So say this is the condition after say push 6. Okay. So after push 6, tell me what will be the value of stack pointer?
Sir, 08.
Okay, right, 08, and these are definitely your addresses, right? So say initially all the address are empty, nothing is there. So will there be any change in this address section, or I mean, will there be any content in any address after this instruction push 6? This one 0B, 0A, 09, all these are addresses, okay? So I'm specifying the content. So assume the contents are empty. So after push 6, will there be any change in the content of this register or in any of the registers over here? Will there be any change?
No, sir.
So what is the significance of this push 6? What is happening? When you write, I mean, when you are executing this line, then what is actually happening? What is the meaning of push? I just said, what is the meaning of push? When you want to store the content of a register in a stack, then that is known as push. And I said that we always push with the specific address. So we are writing push 6. What is the meaning of this? The meaning of this is your address 6 contains a register, definitely. So the content of that register will be pushed onto the stack. So what will be the change?
So the value of R6 maybe will be in the
Exactly, the value of R6 will be pushed onto the stack. Now this entire address is stack. So where will the value of R6 go? In which location?
It's 08.
Exactly, it will go to 08. That is what, try, even if you're wrong, okay, you have to try. Definitely, I'm not writing hex because by default it is hex. So see, initially your stack pointer is 07. Okay, your stack pointer is at 07. At this condition, it is encountering this instruction, that is push 6. So whatever content you are trying to push will be stored in the next address that your stack pointer is indicating. So your stack pointer is having the value 07. So the content that will be pushed immediately will go to the address 08. So that's why in 08 you have got this value. Okay. So let's take another. So after say push 1, after push 1, this is the scenario. So now tell me what will be the changes.
Sir, in 09, the value will be 12H.
Exactly 12, and in 08 you had 25, so it will remain as 25, isn't it?
Yes, sir.
And what will be the value of stack pointer?
So 09.
Exactly 09. So after the last push, that is your push 4, after push 4, 08 will still contain 25, your 9 will contain 12, and your 0A will contain what?
Sir,
Sir,
0.
0F3.
Exactly. Okay, you can simply write F3. And what will be the value of stack pointer?
Sir, A.
Exactly. A or 0A, whatever you like. Yeah, that is right. So is this example understood to everyone? Please understand this example. If you have doubt, ask. No
Sir,
question.
we have seen that every time we are pushing something, the stack pointer will increase by 1. So what about the stack pointer from 0 to 6? will those remain unused?
0 to 6 so say again বুঝি নাই কোশ্চেনটা
মানে স্যার আমরা তো এসপি স্যার শুরু করতেছি 7 থেকে স্যার, তো 7 এর আগের গুলো স্যার কি হবে? কারণ
no, okay, okay, I got your point. If you have your class note, please go to the last figure that we discussed. I mean the RAM allocation. Over there, you see that your 00 address from 00 to 07 is for your register bank 0, and only register bank 1 is for stack, and the address of register bank 1 starts from 08. So only the address 08 to 0F is your stack memory. Nothing else is your stack memory. Only
sir,
address
understood.
08 to 05 you can use for a stack. If you still need more stack, you have to go to scratchpad RAM. Okay, I mean in stack we have got only 8 registers, but say you need more registers for stack operation. In that case, you can move on to scratchpad RAM. We'll see an example that involves scratchpad RAM. Don't worry. Okay, any other question? Anyone? Okay, if there is no question, I'll move. As I said, we are running out of time, so I need to go a little bit fast. So if you have any question, you have to ask instantaneously. Okay? Okay, look at the example. So this is your instruction, and this is your initial condition, as you can see. Okay, so initially the value of stack pointer is 0b, and even if I do not specify the value of stack pointer and I provide you just this figure, you need to understand that the value of stack pointer is 0b, because the value of stack pointer or the stack pointer will always indicate the highest or the topmost address within the stack. Okay, so if I show you only this portion of figure, you have to understand that the value of stack pointer is definitely 0b. If that is the case, then after pop 3, I mean, when we go for pop 3, then what will happen?
So 54 will be copied to register R3. Okay.
Exactly, 54 will be copied to register R3. So your R3 will contain the value 54 hex, and this one will be empty. Your 0A will still contain F9, 09 will still contain 76, 08 will still contain, and what is the value of stack pointer?
0A.
Exactly, very simple, 0A. So, okay, for the next one, when we go for pop 5, your R5 will contain which value?
So F9.
F9, exactly. So your R5 will contain 0, F9H. So these two will become empty. Your 9 address will contain 76. This will contain 60. And what is the value of stack pointer?
09.
09, very simple. And finally, when we go for pop 2, your R2 will contain what? What will your R2 contain?
76.
Exactly, very simple. 76 in hex. And your 8 will still have the value 60, and your stack pointer will have the value 08. So is it understood, everyone? If there is any confusion, any question, you can always ask. The important thing, we always, for push and pop instruction, we always specify the address and not the name of the registers. Okay, don't forget this question. For all type of push and pop operation, we use the value of, I mean, we use the address. We do not use the name of the register. Okay, so whatever
Sir,
this,
sir, can you repeat the first part where you selected SP as 0B?
Oh, SP as 0B. Okay. Remember that your stack pointer will always contain the address of the highest or topmost stack address. I mean, what is your stack address? Okay, this is your register bank 1. So this is your stack, isn't it? So what is the range of your stack? The range of your stack is from 08 up to 08, isn't it?
Yes, sir.
So your stack pointer will always contain to the highest address which has some content. I mean, in this particular figure, you see that 08, 09, 0A and 0B, all of them have got some content within themselves, right?
Yes,
So
sir.
definitely the value of stack pointer will be 0B. I mean, it will point to the highest address. If I come over here and if I do not specify this stack pointer, you need to understand that your stack pointer will have the value 0A, because above 0A we have got 0B, but 0B is empty. So forget about 0B, the highest one is 0A. So the value of stack pointer will be 0A. These are your normal scenario. Of course, within a specific instruction, you can change your stack pointer, but I'm talking about normal scenario. Until and unless you do not touch the stack pointer. Like this is again a normal scenario. Pop 3, pop 5, pop 2. So we understand that these registers R3, R5 and R2, they are of register bank 0. So until and unless we do not select other register bank, by default the register bank is 0. So the similar thing. Until and unless specified something else, your stack pointer will contain the highest address which has some content. Is it okay?
Yes, sir.
See the last example, and with this example we'll finish chapter 2 and try to understand this example. Okay, so as we discussed that we have got only 8 bytes of memory selected for stack. So what will happen if we need some more memory, right? So in those cases we can use the scratch pad RAM, but to use the scratch pad RAM you need to specify the value of stack pointer in that particular manner. So see the example, you will understand. This is your example 2.10 of the book. Okay, so assume you have been given this set of code. Okay. Now I'm asking you that write some push instruction which will push the content of these registers onto the stack. So what will be your instruction? Say, let's see. So my question is, again I'm repeating, say you have been given this information. The code that you can see, you have been given this information. Now your task is you need to push the contents of all these 4 registers onto the stack. So how can you do that?
Sir, in the last line, you wrote move A. So can we write like this?
Yeah, you can move A, then something. So you are moving this value into register A. Of course, you can do that. I mean, if you can write move R2 hashtag 058, you can definitely write move A0. I mean, this R2 is also a register, A is also a register, and both are 8-bit registers. So you can do that.
So in case of R2 and R1 and R0, we can use 0, 1, 2, similar to this A, right, sir?
0, 1, oh. No. This
And-
A is not an address. This is your accumulator register.
Okay, sir.
You cannot directly move to an address. This is your accumulator register. I now I got your question. This A is not an address. Okay, this is your accumulator register. Have you got your answer?
Yes, sir. But in this case, sir, what is the address of this accumulator register?
Yeah, I will provide you the address. Don't worry. I mean, before coming to A, first of all, help me push these registers. Then I will help you push this A. Before
The
that,
push 0, 1, 2.
push 0, 1, 2. What about others? What do you think? Okay, thank you for your approach. At least you tried. Push 0, then push 1, then push 2. What about others? Do you think he is right?
No, sir. It will be push 1, 8.
Push 1, 8.
Yes, sir. And push 1, 9. And
Sorry, sir. The
Oh.
SP is in 4F position. So
SP is in 4F. So
I think we have to move the SP first.
no. You are selecting the SP because I will ask another question related to this SP. For the time being, forget about this SP. Don't worry about this SP. Just concentrate on this portion. Just concentrate on this portion. Now tell me, what will be the push instructions?
Sir, just like my friend Ratul said, sir, it should be, sir, push 18, 19, and 1A. I think.
Why are you saying 18, 19, and 1A? What is your explanation? Okay, let me
Sir,
get back to this.
as
Wait.
So this is because PSW3.
Okay, now tell me. Yeah.
Sir, bank 3. We are using bank 3.
Yes, sir, we are using bank 3, sir.
How are you? How do you know that you are using bank 3?
Sir, there used, sir, an instruction called, sir, PSW, sir.
PSW.3 is for
Set
bank
B
0.
PSW3.
Okay, PSW.3. So what is the meaning of
Sir,
this?
bank 0.
Sir, this actually means that we are switching to register bank 3.
So let's try to be more specific. how you are determining this. Okay, so let me get back. Okay, so for getting back, I got a message.
So
Okay.
PSW.3 denotes R0, so it should be bank 0.
PSW.3 denotes R0.
Yes, sir.
Let me draw the PSW flag. I think you are getting confused a little bit. Okay, so if I draw this, first of all, we have got carry, then we got auxiliary, then we got F0, then we got RS1, then we got RS0, then we have got overflow flag, then we something that we don't need, then we got parity flag. So this is your PSW bit 0, right? Then this is your 1, then 2, then 3, then 4, 5, 6, and 7. Okay. How do we determine bank? We the selection of bank depends on RS1 and RS0. All right. So if it is 0, 0, this is our say bank. Our bank is 0. If it is 0, 1, bank is 1. If it is 1, 0, bank is 2. If it is 1, 1, bank is 3. Right? We discussed this, isn't it? This is not new to you, isn't it? Okay. Now let's come to this next one. So PSW.3, we are writing set bit PSW.3. That means set bit means we will make this bit as 1. So which is your third bit? Which one is your third bit?
RS0.
RS0. So you are making RS0 as 0. So if you are making RS0 as 0, then that means your RS0 is 0 is over here and over here. So what is the value of RS1? Until and unless specified, the value is always 0, isn't it? So the value
Sir,
is 0.
why did we make RS0 equals to 0?
Sorry.
So set byte, so it should be 1.
Right. Set bit, it should be 1. Extremely sorry, yeah. So 1 is either this or this, right? So either bank 1 or bank 3, but we don't know the value of RS1, right? So until and unless the value is specified, we always assume 0. So this is your combination. So what is your bank?
Bank 1.
Exactly, bank 1. So some of you are saying bank 0, some are saying bank 3, but in fact it is your bank 1. Okay, so now we have got the solution that the bank we have selected is 0. Yeah, sorry, bank 1. Yeah, sir.
Sir, can you repeat the set bit theory again?
Okay, set bit PSW.3, meaning that in PSW register, set the third bit to 1. That is known as set bit. So which one is your third bit? This is your third bit. So set this bit to 1. So that's why this has become 1. I mean, we are selecting this one. Is it okay?
Yes, sir.
Okay. Now tell me, what will be the push instructions?
Push 8, 9, and 1A.
Exactly. So the instructions will be push 8, then push 9, and push 1A or 0A?
0A.
Exactly, 0A, and now you need to specify hex. Okay, and definitely you don't know the address of A. That is fine. The address of A will be discussed in chapter 4. For the time being, I'm just providing you with the address. So the address of A is 0E08. So your last instruction will be push 0E08. Is it understood, everyone?
Sir, can you repeat the push part again?
All right. So see, when we have got this specific line, now you need to be careful about your register bank. So what we are writing, set bit PSW.3. The meaning is the third bit of PSW, set that bit to 1. So this bit will become 1. And if you remember, your RS1 and RS0 determines which bank is selected. So for RS1, nothing is set. In this particular example, you see, for RS1, nothing is set. So if nothing is set, you will assume this to be 0. So that means this one is 0 and this one is 1. So if that is the case, we are in bank 1. So if we are in bank 1, I need to come over here. So if we are in bank 1, what are the address? 8, 9, A, B, C, D, E, F. And the name is same, R02, R7. So go back. So what are our registers? R0, R1, and R2. So what was the starting address of your bank 1? The starting address was 8. So for R0, we will write push 8. For R1, we will write push 9. For R2, we will write push 0A8. And your register A is a special register. Actually, this is known as your SFR. We will discuss this in chapter 4. Okay, and the address of this accumulator register is 0E0H. So we are writing push 0E0H. So is it okay now? Understood?
Yes, sir.
Any question? All right. Now the next question comes. This was the first portion of our problem. Now the second portion of our problem is specify the address of the stack and the contents within the stack. So you are writing push 8. So where will the value of this 8? I mean, where will the value of this R0 go? Tell me the address and the value. What will be the address?
50.
Exactly. Your address will be 50. And this is the content. And your content will be
So 25H.
25H. Exactly. The next address will be 51. The content will be 0CH. The next content will be 52. And your value will be 52. And the content will be 05H. Finally 53 and E0H. Sorry. That is the address. Sorry. The content is C. And where are these addresses? If you remember, this is the address in your Scratchpad RAM. So see, by moving this stack pointer, you can change the location of the stack. By default, you have register bank 1 for your stack. But if you cannot use that, then you can go to Scratchpad RAM and use that as stack. Is it okay now? If you have any, this is the end of your chapter 2. So if you have any question, you can ask. Have you understood how the address started at 50?
So can you repeat that part again?
Which portion? Tell me.
So why the address is up from 50 to 50?
Exactly. Okay.
Because of
So-
increment.
Yeah, exactly. So see, your stack, the value in stack pointer is 4FH, right? So the value is 4FH. So if you add 1 with 4FH, you get the address 50. So if I go back to the previous example over here, you see initially the stack pointer, the value was 07. And when we executed our first push, the content was moved to 08. That means the next address that your stack pointer is containing, it will go to that particular address. So your stack pointer was containing 07, but you stored the value in 08. So the same logic applies over here. Your stack pointer is containing 4FH. So if you add 1, then that becomes the address where your content will be stored within the stack. Did you get your answer?
Yes, I understood it. Thank you.
Any other question, anyone? Fine. So if there are no other questions, then this is where your chapter 2 ends and we will start chapter 3 today. So chapter 3 mainly deals with your jump, loop, and call instructions. Most of these things you already know. The problem will only be that in your previous course, you did not have to worry about the addresses or the corresponding addresses. You only dealt with your these instructions, jump, loop, and call. But over here, when we come over in microcontroller 8051, you see, you need to deal with the addresses as well. So that is what makes the main difference. All right. So you know what is looping. There is nothing to explain what is the meaning of loop, and the syntax is this one. So DJNZ register level, the elaboration is decrease this register and jump to this level if not 0. So I repeat, the full form is something like this: decrease this register and jump to this level if the value is not 0. Understood this full form? We'll see an example. So let's see an example. I think it will be clearer. All right, so try to understand what is happening. So first line, what we are doing, move A 0. So the register A contains the value 0. Then move R2 10. So what is the value of R2? Your R2 contains the value 10. All right. So this is a label, you know, again. Add A hashtag 25. That means now your accumulator contains the value 25 because previously it had 0. So 0 plus 25 will give it 25. Decrease R2. All right. So now your R2 becomes 9. Okay. Decrease R2 and jump to again if not 0. Okay. R2 is not yet 0. So I'll jump to again. When I come to add, when I come to again, I encountered this instruction that add A25. So I will add 25 with this. Again, I'll come over here. R2 will become 8. Again, I will add 25 and so on. And it will keep decreasing. So basically this one, and finally you move the result to R5. So basically this gives you the result of 25 into 10. Your A will contain the result of 25 into 10. So we are multiplying with the help of loop. Is this example understood?
So could you repeat that?
Which portion you want me to repeat?
So is again part of the syntax? I think I
Yes. Again is part of the syntax. Let me go back. You see, we have got label, right? The syntax is DJNZ, then register, then label. So we have got DJNZ, then register, then label. So again, I'm saying the full form is decrease R2 and jump to again if the value of R2 is not 0. So decrease R2 and jump to again if the value of R2 is not 0. So when the value of R2 will become 0, it will not jump and it will come to this line. So whatever you had in A will be moved to R5. So your R5 actually will contain this result, 25 into 10. It will contain this result. Understood? Is it clear, everyone? Come on, yes, no, maybe. It cannot be maybe.
Yes, sir.
Either yes or no. Now let me
Yes,
ask,
sir.
okay. Now let me ask you a question. What is the maximum count that you can perform within a loop? I mean, this one we loop for 10 times, isn't it? So what is the maximum number of count that you can execute with loop?
2 to the power 8.
Exactly, 2 to the power 8. How much is that? 256. So what happens if you have to loop more than 256 times? What will you do then?
Double leveling.
Exactly, you will use double leveling. So let us see an example with double leveling. So this is your example 3.3 of the book. Okay, look at the code and tell me how many times did we loop? How many times did we loop? Exactly. We looped for 700 times. Those who did not understand, okay? So what we did, first of all, we moved the value 55 into A. I mean, you can move any value. I mean, this is not significant over here. These two lines are actually significant. Then move R3 10. All right. So your R3 will have the value 10. Then move R2 70 and R2 will have the value 70. Fine. Again, complement. CPL stands for complement. Okay. So it will complement A. Now come over here. Decrease R2 and jump to again if R2 is not 0. So what is the value of R2? R2 value is 70. Okay, now R2 will become 69, it will become 68, and finally it will become 0. Okay. Once R2 becomes 0 in this line, remember your R3 is still 10. So once R2 becomes 0 in this line, your your assembler will come over here and it will decrease R3. Now R3 will become 9. Okay, and it will jump to next. When you go to next, you see you are again moving 70 to R2. So R2 was previously 0. Now once again your R2 is loaded with 70. Now come over here to complement A and again it will start decreasing R2. So again it will be 69, 68 and up to 0. Then again your R3 will become 8. Again your R2 will start from 70. Again it will become 0. So you see this process will continue 10 times. I mean you will decrease R3 10 times. And in each time you will complement or you will loop for 70 times. So 70 into 10 makes it 700. So this is how you find out how many times you have looped. Is it clear, everyone?
Yes, sir.
Okay, so that means using inner loops, I mean using multiple loops, you can loop for any number of time that you want. Okay, it totally depends on the programmer how he wants to design or what he wants to do. Okay, so this is how you loop. this is your table 3.1 of the book. All right, so these are your other conditional jumps. So very simple, if you just write JZ, it will check for the accumulator. That is jump if accumulator is 0. Jump not 0, the opposite of jump 0. CJNEA data, that means compare and jump if not equal. Okay, so compare accumulator with data. If it is not equal, then jump. So compare and jump if not equal. The following is the same thing. The difference is over here we have got a register and hashtag data, and you know the difference between data and hashtag data. So the same thing. So jump if carry. So it will check for the carry bit. Remember CY. It will not check the flag. It will check the carry bit only. So jump no carry, opposite of this one. So jump bit. So jump if bit is equal to 1, and there is opposite instruction JNB, that is jump if bit is equal to 0. And finally JBC, jump if bit is equal to 1 and then clear the bit. So is it okay? So if there is any question over here, you can ask.
So could you repeat what CY means?
Say again.
So CY ta ki carry bit. I got confused. You said carry, not flag.
CY is this one. This one is CY. The bit 7 of PSW. Okay. Right, so I think we can stop over here because after this I've got an example. It will take some time to discuss the example, so I think I'll stop over here. Okay, so do you have any question up to this? There are no questions.
Sir, can you repeat the example 3.3 again? 3.3. Yes, sir.
Okay. Which portion did you not understand? Tell me.
Sir, the R3 is 10, then R2 is decreasing, but how then R2 is 0, then again R3 is 9. From this point, I did not understand. From the second portion, sir, after
so
700 times.
After 700.
Sir, in the red.
Portion. Okay, so before the initially R3 is 10, right? You understood this portion.
Yes, sir.
And R2 is 70. So when I am in this particular line, from here you will always go to this level as long as R2 does not become 0, isn't it?
Yes, sir.
So once R2 becomes 0, instead of going over there, you come in this line, right? Over here, see, you will decrease R3. So now your R3 becomes 9. So when after making R3 9, where do you jump? You jump to next. That means you are coming in this level. So see what is happening over here. Over here, again you are loading your R2 with 70, right?
Yes, sir.
Then after that you will complement A, fine. Then again you will come over here. So see, when you come over here, you will from this line you will go to this again level for another 70 times, right?
Yes, sir.
Then again you will decrement R3 to 8. Then again you will repeat this process. So how many times will it take place? It will take place 10 into 70 times. So that is how we got 700. Did you understand?
Yes, sir. Thank you.
Okay. Yes. I'll just take the attendance and leave. Those who are leaving, at least inform your friends so that they can let me know that you have informed them. Okay. Okay. Is there any other question? All right. If there are no other questions, let me just take your attendance, and after that, I'll let you leave.